So welcome back to the second last lesson. And today we're going to talk about trigonometry. So it's going to be an extension of like triangles and stuff you have learned in junior high. So let's do a little bit of review. So you probably knew this theorem from a long time ago, but the Pythagorean theorem, what it allows us to do is that, okay, let's basically repeat it first. So it's a squared plus b squared is equal to c squared. So what this theorem allows us to do is that if we have two sides of a triangle, for a right triangle, it allows us to find the third side. So here in the formula, A and B are the two legs of the triangle. So if we draw a right triangle, the two short sides will be the legs. So the ones beside the right triangle, right angle. And then the third one will be the hypotenuse or C, which is the longest side. So for example, if we have a triangle with legs AB equal to 3 and 4.
Out of proportion?
Yep. So what we can do now is that we can use the Pythagorean theorem to find the hypotenuse, the side unknown. So it's a squared plus b squared is equal to c squared. In this case, a could be 3 and b could be 4. And then we could simply solve this and get that c is equal to 5. And even though there's a square, we don't do negatives because there's no negative sides in a triangle. I think that's pretty obvious.
Yeah, and something interesting to note here is that when you find the Pythagorean triples, so a Pythagorean triples basically means the sides of a right triangle. So for example, 3, 4, and 5. Any multiples of these numbers will also give you a Pythagorean triple. So for example, if we double everything, 6, 8, and 10, this is also a Pythagorean triple because 6 squared plus 8 squared equals 10 squared. And like if we multiply it by 3, so 9, 12, and 15, it's also a Pythagorean triple. Okay.
Okay, yes. So what it also allows us to do is that when you have for example, the three sides, if you don't know if the triangle is a right triangle, you could put all the sides into the formula, basically test like three possibilities. And if it works out, then that means the triangle is a right triangle. So that's probably not going to be really useful, but it's just something nice to know.
Yeah, it is.
Yeah. So we can see that there's currently a limitation to this way of finding sides. For example, if we have a right triangle and we know one side and one angle, then we're kind of stuck. There's no way to use the Pythagorean theorem. However, in this case, trigonometry can come into the rescue. So we should actually draw a diagram of the trigonometry triangle. So the right triangle again, but this time we're going to label it a little differently. So for an angle that we don't know, we would call it a theta. So it's a Greek letter. It's a little zero with a line through it. That's called theta. So that's an angle that we don't know, actually, or could know, but in this case, it's just don't know. And then now what we can do is that instead of putting A, B, and C as the sides, what we label it as is a adjacent. So in this case, the adjacent side will be the one right beside the theta, and that is not the hypotenuse. And obviously we have the hypotenuse, which is the longest side. And the last one is called the opposite, because this is directly opposite of the theta angle.
How do you spell hypotenuse? We just quickly.
I think that's correct.
Okay. Yeah, I think we should just elaborate more on like how to find the adjacent, hypotenuse, and opposite.
Okay, yes. So if we have a right triangle, what you can do is that you can label the hypotenuse right away because it's a side directly across of the 90-degree angle. My voice just died then. Okay.
So yeah, just like what David said, the hypotenuse is the longest side of the triangle, right triangle.
Yeah.
And it is directly opposite to the right angle. So as we can see here, it is directly opposite to the corner. The opposite side is the side that is opposite to the angle that we're studying. So in this case, because we're studying uh, theta right here, the opposite side would just be the side that's directly across from it. So I guess like we could say side that is opposite to the studied angle. And then finally, we have adjacent. The adjacent is the side that is the closest to the angle, but that's not the hypotenuse. So since the angle we're studying is theta, there are two sides that are close to it, the adjacent side and the hypotenuse side. The adjacent side is the side that is not the longest, so not the hypotenuse.
Yeah. So theta is technically formed by the adjacent side and the hypotenuse side.
Yeah, exactly.
Okay, so should we like do a little bit of a test for them?
Yeah, sure.
Just like draw a random orientation of a triangle and let them
Yeah.
determine which sides.
Yeah, I think that would work. Do you have an example in mind?
I mean, I don't think we have to give measurements. Just
Okay.
like, yeah, draw a random orientation of a right triangle. And then
Okay.
just put like ABC and then let them like fill it in. A is something.
Sure.
Yes, that's a good drawing.
Uh, what angle are we studying? The top one or the bottom one?
We can do the top one.
Okay. So yeah, this one is for you guys to try out. Just correspond each of A, B, C to one of the sides of a triangle. So whether it's the hypotenuse, adjacent, or opposite.
Yes, Edward, that's correct.
Yes. So A is adjacent. B is hypotenuse. And C is the opposite. Yeah, great job. David, do you want to like explain why that is?
Yes. Okay. So we can first identify the hypotenuse. If we kind of look at it, it is the longest side. And another way to look at it is that we can see the 90-degree angle, the right angle, and we just go straight across from it and we find the hypotenuse. And then if we look at the angle theta, we can see that it's made up of the hypotenuse. We already identified that. And then there's one more side it's made of, and that has to be the adjacent.
Yeah.
And then if we just look right across from theta, like we did with the hypotenuse, we can see that there's the opposite side.
Okay, nice. Should we do another example?
Oh, we should.
Okay. Oops. Do you want to say like this angle right here?
Oh, yep, sure.
Okay. So same thing as the last question.
Okay, yes, that's correct and very quick.
Yes. Oh yeah, just one thing to note, the angle that we're studying is never the right triangle. I mean, the right angle, right? We can never call we can never derive these sides from a right angle because if we like pretend that we're studying the right angle right over here, then the opposite is hypotenuse, which is correct. But then there is no opposite or adjacent because firstly, the opposite is already the hypotenuse, so you won't have an opposite side. But then you have two adjacent sides, which is clearly wrong. Okay, should we do
Okay,
like one more?
I think they get it.
Okay, yeah, that's fine.
Yeah. Okay, so now that we kind of know what the triangle looks like in trigonometry, we can finally know what the three trigonometry ratios are. So the first one we're going to go over is sine. So it's sin, and then it's theta, and it equals to a ratio which is equal to the opposite over the hypotenuse. So it's the length of the opposite side over the length of the hypotenuse. The next one is called cosine. We short write it as COS, cos, and it's the adjacent over the hypotenuse. And the last one is called the tangent. We write it as tan theta, and it equals to the opposite over the adjacent. Okay, so we can like draw it a little triangle, and we can like find out what its trig ratios are. Yeah, SOHCAHTOA. That's the phrase that you want to remember. So to basically split it apart, we have the first letter S, which stands for sine, and OH stands for opposite over hypotenuse. And then the second one is Ka, which is C for cosine and adjacent over hypotenuse. And the last one is Toa, T, which is tangent, opposite over adjacent. So yeah, that's like a nice phrase to remember.
Yeah.
Yeah, and I don't know why, but I always associate with Moana for some reason, that movie.
Oh, that's interesting. Okay, so you're saying to draw a triangle. So
Yeah, let's like identify the trig ratios of a triangle.
sure. Okay, so let's say we're studying this angle right here. And this would be the adjacent side, this would be the opposite side, and this would be the hypotenuse.
Should we give them numbers or just like variables?
Oh, okay, we can give numbers, but I thought we are gonna do like a general one for this.
Oh, okay, we can do a general one.
Yeah. So like in this case, sine theta would be opposite over hypotenuse. Cosine theta would be adjacent over hypotenuse, and tangent theta would be opposite over adjacent. So now, do you want to give like numbers?
Yeah, sure, we can give out some numbers.
Okay.
Wait, do we want to give like numbers for all the sides and all the angles, or?
We can give like two sides.
Okay,
So like maybe like 3 and 5 or something.
yeah, that works really nice.
Yeah. Do you want to do this one together or?
I think we should do this one together.
Okay. All right. So I guess I can explain the first step to find the other side. And
Okay.
okay, so for the first step, we're trying to find the third side, the unknown side of the triangle. So since we're not given the side of the triangle, we have to use the Pythagorean theorem to find it. So we can see that leg 1 is 3. We don't know the length of the leg 2. And the hypotenuse is 5. So we can use the Pythagorean theorem to figure out what b is. A squared plus b squared equals c squared. So that would be 9 plus b squared equals to 25. B squared equals 16, so b is 4. So now we can replace the question mark with 4.
Okay, wait, are we finding the angle now? Oh
Uh,
yeah, okay.
yeah.
So sine theta will be the opposite of the hypotenuse, so it's 4/5. And cosine theta will be the adjacent over the hypotenuse, so the adjacent is 3, so it's 3/5. And tangent is the opposite over the adjacent, so it's the opposite 4, and the adjacent 3, so it's 4/3. And if you have a calculator, you can find the degrees for theta. So not sure, should we do that?
Like you mean like the inverse tangent, like
Yeah,
inverse
inverse
sine?
sine.
Oh yeah, sure. Okay.
Okay, actually, we don't have a picture of like a calculator.
That's fine. We can just like draw the notation out.
Yeah, okay, I'll just do it on my calculator.
Okay.
I gotta make sure it's in degrees. Yeah. Okay, so sine, the inverse sine of 4/5 will give you theta. So in this case, if you do it on a calculator, if you look on your calculator, scientific or graphing, you'll see the sine, cosine, tangent buttons. And most likely you'll have a key named second or shift. You click on that, and if you look above the sine, cosine, tangent keys, you'll see a little icon which kind of is like the one that Kevin drew out. It's like sine or with a -1. That will be the inverse. So what you would do is that you would inverse the ratio and it will give you the degrees of the angle. So in this case, sine theta will be equal, the theta will be equal to 53.13 degrees.
Yeah. So sine inverse, you use sine inverse when you know the trigonometric ratio and you want to find out the angle. So yes, ratio to angle. Okay, now note sine inverse of 4/5 does not equal to sine of 5/4, nor does it equal to 1 over sine of 4/5. So this notation right here, this inverse, is not anything that we've seen before. So don't confuse it with like reciprocals.
Yeah. And some people, instead of writing sine -1, they write arc sine to like better identify it so people don't make mistakes. But
Yeah.
calculators have sine -1, so we're just going to use that.
Yeah, let's just use sine inverse -1.
Yeah. And we can do the same for cosine and tangent. So cosine will be equal to 53.1, yeah, 53.1
Wait, what?
degrees. Yeah, I don't know what happened with my calculator.
Wait, but that they're the same angles.
Did I switch it? Okay, well, I think my calculator's broken. Try yours.
Yeah, I'm doing it online.
Yeah, I don't know how it ended up with the same number. Wait, what if it is the same number?
Oh wait.
Uh,
Okay. Yeah, it,
this is
it should be the
awkward.
same number because theta, we're describing theta.
Okay, yeah, wait, okay.
Never mind.
We both freaked out. Yeah, the angle didn't change because it's the same angle.
Yeah.
Is it okay if we don't have scientific? If you're going to high school, you like most definitely want to get a graphing calculator.
Yeah.
Yeah. So maybe if you have time, you can buy like a new one or a secondhand one. But yeah, I think a graphing calculator is just required in high school. But if you're not going to high school right now, you should be fine.
Hmm. You definitely won't need one for this course if you're wondering.
Yeah. And you'll never hand calculate arc sines and arc cosines.
Yeah. I know, like, I think you can like calculate basically everything online, but the reason you want a graphing calculator is to use it in tests. So like when you
Yeah.
have a test, you can't have your phone with you. So in that case, you want to have a graphing calculator.
Yeah. If you don't have a graphing calculator right now and you need an online one, Desmos is a great website.
Yeah. Yeah, feel
Really
free
nice
to
graph.
use that.
Yeah.
Okay, so 10 inverse of 4/3 should give
Yeah,
us
should
the
be the
same
same.
angle.
Yes.
Yeah, so theta is 53.1 degrees.
Yeah. Should we find the other angle?
Yeah, sure.
Okay. Yeah, we can have theta 2, I guess we could call it. Or we could just
Okay.
rename it theta again.
We could just like 90 minus this. We don't have to name
Yeah,
it.
that's true.
So for the single right here, 53.1 degrees plus 90 degrees plus whatever that angle is equals 180 degrees. So we know that this angle should be 36.9, I believe. Is that true?
Yeah. Wait. Here, math moment.
Yes.
Yeah, you got it correct.
Okay, nice. And obviously this is 90 degrees.
Yeah.
Okay, should we
Should we try finding a missing side with an angle and a side?
missing side? Oh, like the horizontal vertical components thing?
Oh, we're getting into physics all of a sudden.
We can do a physics example because
Yeah, we can do a physics example.
yeah. Okay, so do you have a question in mind?
Absolutely not. I'll try to
Okay.
make one up. Wait, are we doing like components?
Yeah.
Okay, great. Okay, so we can try to find the hypotenuse, so the resultant, and we have 20 meters as the bottom, and then we can have I don't know if this works out actually. We have 80 degrees on top.
On
Wait, this
top.
doesn't work out at all.
No, it does. It does. It's fine.
Okay. So you have 90, and that means the bottom angle. We already know that one, but we can have wait, it's gotta be smaller than that. Oh my gosh.
It's fine. It'll work out.
Yeah, okay, let's just find the hypotenuse. This is
Okay.
not a physics question anymore.
Yeah, it's fine. We don't need one.
Okay, so right now we can do it two ways. We could either use the angle 80 degrees on top and do a cosine. Wait,
Sine, I think.
sine? Yeah, okay, wait, never mind. Yeah, sine. Or we could instead figure out the other angle and do a cosine.
Let's do both ways actually.
Okay, yeah, let's do the sine method first.
Yeah.
Okay, so we know sine 80 is equal to the opposite of hypotenuse. It's 20 over question mark.
X.
Yeah, x. You should name it. Now what we can do is that we can reorder the equation a little bit, and we get x is equal to 20 over sine 80. Now, I don't think there will be a nice answer for this one.
We can just use our I can just use my
Yeah.
calculator.
Yes. So if you plug in the equation into your calculator, you'll see that x is roughly equal to 20.31, estimated a little bit.
Yeah, 3-1.
So we know the hypotenuse is 20.31 meters. And just to really double check this, what we can do is that we can try out the other method with the cosine.
Yep.
So we know two of the angles. We can find out the third one is 180 minus 80 plus 90. So it's 10 degrees, theta. Yes, 180 minus 80 plus 90. No, minus 90, yes. Okay, 10 degrees. So what we can do now is that we can say cosine theta, which is cosine 10 degrees, is equal to the adjacent over the hypotenuse, and the adjacent is 20. Oh,
Adjacent over hypotenuse.
so the adjacent is 20, and the hypotenuse is unknown. We just mark it as x. And we can rearrange the equation again. We get x is equal to 20 over cosine 10. And now if we use our calculator, we should get the same number. And yes, it is roughly 20.31.
Yeah. Thank goodness it is.
Yeah, thank goodness.
Okay, and so if you want to find out the other side, you would simply just use Pythagorean's theorem. So I guess we could do that quickly.
Yes. Or what we can do is that we can be pros and use tangent.
Oh, okay. All right.
Yeah, well, we
So
know the answer already, but we can double check, you know? It's always great
yeah.
to double check. Yeah, so we can use tangent. So in this case, we can say theta is equal to 80 degrees. And say tangent. Oh, Edward said, huh? For me, it says
Oh, it's
negative
because you're
20.
in radians.
Yeah. So wait, what type of calculator do you have? Is it a scientific or is it oh, Desmos? Okay.
Let me see.
Oh, I gave you the graphing calculator. Whoops.
Oh,
Yeah, I should give you the scientific one.
Edward, the reason it says negative 23 for you is because you're not using degrees, you're using radians.
Yes, Edward, try out this one. This one should work.
Yeah, that one should work.
Okay, so if anyone has a graphing calculator here, for grade 10, for math 10, you should most likely go to the top left of your calculator. You'll see a button called mode, and you should scroll down to the third line, and there should be an option between radian and yeah, it shows 20.3. Okay, good, that's good.
Nice.
Yeah. So in your mode of your graphing calculator, you should select degree because if you select radians and you do a test, well, good luck.
Yes. I know a friend who did that and he pretty much failed the test.
Yeah. Your teacher will most likely tell you before the test to
Yeah.
switch to degrees.
Oh yeah, I think it's a good time to like tell them that like before taking tests, you should check that sine 30 is 1/2.
Yes.
Okay. So before doing any calculations, always make sure that sine, always check that sine 30 degrees is equal to 0.5. If it's not equal to 0.5, that means it's on radians and you have to like reset it. Right. This is super, super important.
Yeah. If you don't set it, what does radians do? It's another unit for like measuring angles in a circle.
Yeah.
Yeah.
Hard one.
Yes. You'll learn it in like math 30 around there.
Yeah. Or like if you're smart like David, pretty early on.
Well, that's because it was a course for math 30, so
Oh, okay. I see.
yeah, I
Do you
think we
want to
should
like talk about radians?
I don't think we should because it's gonna get real confusing.
Okay, that's fine.
Yeah, we should finish the tan thing. I think that's more important right now.
Yeah, okay.
Yeah, okay. So what we're trying to do is that we're trying to find the side of the 3.5. Pretend we didn't know it was 3.5, so we know that tan 80 degrees is the opposite of the adjacent. We know the opposite, it is 20, and we don't know the adjacent. So we rearrange it again, we get 20 divided by tan 80. And if we calculate it, it should be 3.5. And it is 3.53 roughly.
Yes. Okay, so that was basically a physics question, just without like any physics like constraints in it.
Yeah. Here, should we try to make a physics question? I don't think it'll work out to nice numbers, but I think we can make it make sense.
Yeah, we could. We could.
Yeah. Okay. So pretend we're flying a plane right now, okay? So what we're doing is that we're flying north. So pretend north is directly going upwards on the whiteboard. So when we're flying north and we're going, for example, 50 kilometers an hour, or just 50 something units. And then all of a sudden there's basically wind coming, going towards east, and it's going at 30 kilometers per hour. And okay, how should I word this?
How fast is the plane going, and what angle does it make with the horizon? Maybe.
Yes, that's a really good question.
Okay.
Yes, we should do that. Okay, so we're gonna. Oh, I don't know if that's how the plane works. Okay.
Wait, what? No, I mean
Don't worry,
like
don't worry.
okay.
I don't like that. Don't worry. It's not that bad.
Yeah. Um, I mean we could do this one together, should we?
Yeah, we should actually.
Okay, yeah. So the first question is how fast is the plane going? And the second question is what is theta?
Yeah. Another way to reword the first one, how fast? Basically, we're finding the hypotenuse.
Yeah, hypotenuse. Okay. Do you want to explain it?
Yes. Okay. So we can find out for question one, how fast the hypotenuse. What we can do is that we could just do simple Pythagorean theorem. So a squared plus b squared equals c squared. So 50 squared plus 30 squared gives you the hypotenuse squared. So we just kind of figure it out, and we get that it's roughly 58.331 kilometers per hour, I think. What did you get? Yeah,
I
58.
got the same. Yeah.
Okay, good. So that is how fast we're going. And now to find theta, there's two ways to kind of do it. If you're really into, I don't know, flipping the triangle around, we can kind of move the sides over to make a new triangle. But instead, what we can do is that we could do 90 subtract the inner angle of the triangle. So we can label another angle inside the triangle. We could call it like theta 2. And we can try to find that one instead. And we can see that we have all three sides. We can do basically all the trig ratios. Well, not all, but most. But we don't like imprecise numbers. So the hypotenuse, it's been rounded, so we don't like to use it. So what we'll try to do is that we try to use the nice accurate numbers, so the 50 and 30. And to do that, the only way is to use tangents. So tan theta 2 should be equal to opposite over the adjacent. So the opposite is 30 and the adjacent is 50. So here we have to use the calculator to do the inverse of tan. So, uh-oh.
I can do that part. Or did you already
I
get the
got it.
answer?
Yeah.
Okay.
So if we do the inverse of 30 over 50, we get that theta 2 is roughly 30.96 degrees. And now what we can do is that we could subtract that out of 90 degrees and we get the real theta, which should be around 59.0.
Yeah, the reason we're subtracting 90 is because this is a right triangle. So if we know one angle, we can know its complement by subtracting 90 from it. And wait, David, what did we get again?
I got roughly 59.04. Yeah.
0.4. Okay.
Yeah. So if you're doing physics or you're just doing chemistry 20 and you're on the last unit, this will be vectors. So vector addition.
Yes, vector addition. Don't worry about like the vectors part of it. Just know how to like figure out the sides and angles of a triangle. Okay.
Okay, so let's do a word problem.
Are you sure?
Wait, do we not want to?
I mean, it's probably gonna like take a long time, but sure, we can do
No,
one.
it's like a really short word problem.
Oh, okay, that's fine.
Yeah, okay. So there is a cat stuck up 20 meters in a tree, and a firefighter has to put their ladder at an angle of 80 degrees. So how long is the ladder to reach the tree?
But you never said how tall the tree was.
20 meters.
Oh, okay, sorry.
Yeah.
A ladder.
And the ladder is 80 degrees from the ground, so angled upwards 80 degrees. Should we let them do it or should we do it together?
Oh, we could let them try it.
Okay. Yes. So if you're looking at the ladder from the ground, it's basically 80 degrees. Yeah, okay, let's draw a picture for this.
Yeah.
Yeah. So if the ladder's like that, then if we measure the angle between it and the ground, that should be 80 degrees. Nice picture right there.
I'm trying. 20 meters. Okay.
Yeah, so we're determining the length of the ladder.
Yes.
Felt like we did this with like roughly the same numbers.
Um, I mean,
Yeah,
a lot of it is repetitive, so
yeah. Edward, don't worry. You'll say a lot of didn't we do this in trig, the unit trig. Yeah. It's like literally all the same thing, but they just word it differently.
yeah, and the numbers are different or something.
Yeah. Let me find another interesting question to do.
All right, sure. You got the angles. Try using the trigonometric ratios.
Yeah. So like sine, cosine, tangent.
Yeah.
SOHCAHTOA. So yeah, let me type that in chat as well. SOHCAHTOA. So sine, and it's the first letter over the second letter. Yes, opposite over H. Yes, you got it right, Edward. Yeah, you
Oh,
got it right.
yes. Good job, Edward.
So yeah, I think we should go through this one together.
Yeah. So if you just like draw the trigonometric diagram, we can see that the left angle, oops, left
ST dev P.
uh STD I think it's like a statistic thing. Standard deviation or something.
Yeah.
Oh yeah, it is. Yeah, it's a standard deviation.
Yes.
Okay.
Okay. So here we basically have a simple diagram without the tree and the ladder. So here we're finding the hypotenuse. So to do this, we can see that we have the opposite and the hypotenuse. And the only trig equation that works out is sine. So we have sine 80 is equal to opposite, which is a 20, and the hypotenuse, which is the length that we don't know. And now here we can rearrange the equation to put x on one side, and we get 20 over sine 80. And if we run the calculations through a calculator, we get 20.3.
Mm-hmm.
Yes. And then for word problems, you should write a sentence. Therefore, the ladder is 20.3 meters long or something.
Therefore, ladder. We also have to write a declaration statement. So let x be the length of the ladder.
Yes.
Okay.
Should we do an angle of depression question or?
Angle of depression, sure.
Okay. So it's another word question, but we can just draw a diagram.
All right.
Yeah. So a person standing on top of a 20-meter tall building. Just draw a line that's good enough for a building. And then he sees a dog that is 80 meters from the base of the building, and the dog's on the ground. Yeah, I don't think that proportion works well, but that's a nice dog.
It's fine.
Yeah, that's 80 meters from the dog is 80 meters from the building. And so what is the angle formed by the, what do you call it? The eyesight from the person to the dog. So we can draw like a imaginary line between the person and the dog.
Wait, don't we need like the height of the building?
Oh, it's 20 meters.
Oh, okay, okay.
I think I said that, but oh well.
Probably I just missed it.
Yeah. So what we're trying to do is find the angle of depression. So it's the angle that the hypotenuse makes with the horizon. So we can call that angle theta, I guess.
Yeah, so you're trying to figure out what theta is.
Wait, you want them to do it or should we do it all together?
I think we could let them try it out
Okay.
first.
Yes. Should we do this one together?
Yeah, I think we should.
Oh, wait, Edward said wait. Okay, I think he
Okay.
has an answer.
Right.
Uh-oh.
calculator.
Wait, Edward, what type of equation did you try to do?
Yeah, what equation did you? Wait.
Oh, Edward, you forgot to fill in one of the numbers. You left it as a variable.
Wait, no, I think I think for a normal calculator, you can't use it to solve algebra problems.
Yeah. You have stuff like Wolfram Alpha to help you with that.
Yeah.
Yeah, I don't think this calculator can like solve the variable. So you have to kind of isolate it by itself.
Yeah.
Is fine pi?
No.
No.
You have to use arc sine,
Yeah.
or sine inverse.
Yeah, you could think of the trig functions as like the thing we did like a few lessons ago. So f of x.
Oh yeah, yeah. You
Yeah.
can do
So if
that.
we think of it as f of x, then instead of f, we have the word sine, and instead of x, we have theta. So you can't get whatever's inside of the function out.
Unless you use like inverse.
Yeah, but like,
Yeah, but for this question, you kind of need to use inverse, I think.
yeah,
So
that's very true.
you wanna like do this one together?
Yeah, I think we should do this one together. And I'm also looking at what Edward did, and I think he took like a long route.
Yeah, he's taking the right route, but it's
Yeah,
clever, but it's kind of wrong. It's long.
yeah, it will work in the end.
Yeah.
Yeah, okay. So I think we should go through this one together.
Yeah.
Okay.
Wait.
Oh, okay. So actually, we don't really need a simpler diagram, but what we could do is that we could find the hypotenuse of the triangle and then solve for a different triangle. But instead, what we could do is that we could solve for the angle inside of the already made triangle. So we could create another angle and name it theta 2.
Like this part right here.
Yes.
Okay.
Yeah. It's kind of like what we did with the vector thing. So we have theta 2, and now we can see that we have the opposite and the adjacent. So sine cosine doesn't work, but tan works really nice. So we get 80 over 20. And then now to solve this, we have to inverse the tan or arctan. So we get arctan 80 over 20, and it gives us the theta 2. So now if we input this into our calculator, it should give us 75.96 or something around there.
Yeah, 76. Let's round.
Okay. Yeah, let's round it to 76. And now theta is 90 subtract 76, which is 14.
Yeah.
Yeah,
And,
so
oh, sorry.
oh, you can continue.
Okay, I was gonna do another method.
Oh, okay. Yeah, wait, let's answer Edward's question first. Wait, so arc and -1 are the same? Yeah, it's the exact same, but it's just a different way of writing it.
Yeah. Okay, so now let's look at method 2. Method 2 is kind of like Edward's method. For method 2, we can imagine like a triangle. This is a rectangle. What we can do is actually shift this 20 over to this side. So now this is 20. We can shift this 80 to the top. So now this is 80. So now our triangle looks something like this, as labeled in green. So now we can just use tan again. So tan theta is 20 over 80. Theta is arctan of 20 over 80, which should give us 14 degrees.